Good morning, students. This is your Maths 1 online teaching session. Let us continue with our third chapter, that is polynomials part 2. In the previous session, I had just started with this chapter. Let us quickly recap of the important points what we have covered in the previous session. We started this chapter with the basic definition of polynomial. In an algebraic expression, if the parts of the variable are whole numbers, then the algebraic expression is known as a polynomial. Now, let us quickly revise this with the help of an example. Suppose I give you 1 upon y minus 4. Okay? Is this a polynomial? For that, what you will do? You will shift this y in the numerator. Using laws of indices, it can be written as y raised to minus 1 minus 4. Now have a look at the power of the variable. Is it a whole number which we wanted? No, it's a negative number. What we want for an expression to be a polynomial, the power of the variable should be a whole number. Since it is a negative number, that is minus 1, I can conclude that this algebraic expression is not a polynomial. I hope you have revised the definition that for an expression to be a polynomial, the power of the variable should be a whole number. It cannot be a negative number nor it can be a fraction. Then we have learned about classification of polynomials, which was based on two criteria. Yes, what were those two? First thing, it was based on number of terms. Now, depending on number of terms, polynomials are classified as monomial, binomial and trinomial. I hope you know this. Yes, the second criteria was based on degree. So, if the given expression is having the degree as 1, it is linear. Degree as 2, it is quadratic. And degree as 3, it is cubic. All this we have already covered. Let us move to the next exercise question of the practice set 3.1. But before we do that, I have given you the definition of standard form. If a polynomial is written in descending order of its variables, then it is said to be in standard form. Now, what is the meaning of this? This will be helpful when we are solving question number 6 of 3.1. Write the following polynomials in standard form. What we are supposed to do? We are supposed to write the given polynomial in descending order of its variables. Yes, first one is m cube plus 3 plus 5m. The highest order, the highest number that we can see as an index is 3. So we'll start with that, m raised to 3. Then we should get square, but that term is not there. So we take the next term as 5m and then the constant 3. This is the meaning of writing a given polynomial in standard form. I hope you have understood. It's very easy. What you have to do is, you have to just write in descending power of the variable. The polynomial itself will get arranged in standard form. Okay. Now look at the second one. Such a big polynomial is given. Hunt for the highest order. It is y raised to 5. That should be written first. Then 2y raised to 4 along with the sign. So plus 2y raised to 4. Then plus 3y cube. Then the next number along with the sign minus y square. Then minus 7y and then the constant, that is minus 1 upon 2. This way you can write any given polynomial in its standard form. The only thing that you need to remember is write it in descending power of the variable and write it correctly along with the sign. Okay, I hope it is clear. Let us move to the next very important concept of this chapter, that is coefficient form and index form. It will be useful while solving sums based on synthetic division. Let's see this. Consider x cube plus 3x raised to 5 plus 6 plus x square. In order to write this given polynomial in coefficient form, first step, there are few steps to be followed. The first step is write it in standard form. In the previous slide, I have explained you what is standard form. Start with the highest order, that is 3x raised to 5. Then what you will write? 3x cube, then 3x square, then x and then the constant 6. This is the first step in order to get the coefficient form of any polynomial. What is the first step? To write the given polynomial in standard form. The second step is this. In this form, the term x raised to 4 is missing. I hope you have observed that it is x raised to 5 plus x cube plus x square plus x plus 6. In this, x raised to 4 is missing. Correct? So, for that, what is to be done? We will insert this missing term and write it with 0 coefficient. Never write any other number along with it. Why? Because 0 multiplied by any number is 0. We are not changing the question. We are only inserting the missing coefficient here. That is 0 x raised to 4. Once this is done, you just collect the coefficient. We are writing the coefficient form. You just collect the coefficients here. Coefficient here is 3, 0, nothing means 1, 1, 1 and 6. See this. 3, 0, 1, 1, 1 and 6. This is nothing but coefficient form of this polynomial. I hope you are understanding all the steps how to get the coefficient form. Yes, what care is to be taken? While writing the coefficient, you need to put commas in between the numbers. You do not write 3, 0, 1, 1, 1, 6. It is absolutely wrong. It is not the coefficient form. You need to separate it by commas in between and put it in round bracket. Is it clear? Okay. And the polynomial in equation 1 is the index form. Now this polynomial which I have written by inserting the missing coefficient is nothing but the index form. These are very important two concepts to be used later also in the next exercise practice set sums. Okay. So what are the steps to remember? In order to get a polynomial in coefficient form, write it in standard form first. That is descending order of the power of the variable. If any term is missing, insert that term by writing 0 coefficient and then collect all the coefficient terms in round bracket like this, followed by commas in between. I hope all the steps are clear. Okay. Now a note is written here. Try to understand that. If the degree of the polynomial is n, then its coefficient form has n plus 1 terms. This is just a clue to remember. What is the meaning of this? Let us take this example which is written here. Yes? If the degree of the polynomial, what is the degree of this polynomial? The highest power is 5. So degree of the polynomial is nothing but 5. Then what I have written, its coefficient form has n plus 1 term. N plus 1 term means how many terms? 5 plus 1, 6 terms. Just have a look here. Count this. This is the coefficient form. How many terms are there? 1, 2, 3, 4, 5, 6. This is what is explained in this important concept. That if the degree of a polynomial is n, then its coefficient form has n plus 1 terms. Always one term will be greater than the degree. Is it okay? So this is all about coefficient form. I want you to write this all important points as points to remember in your notebook also, so that while revising for the exam, it will become easy for you. Then let us discuss about coefficient form. Have a look at it. If the polynomial is written in descending power of the variable by adding the missing terms with 0 coefficient, then it is called as an index form. I have already discussed it with you. Have a look at the example given to you. Coefficient form of the polynomial 3x raised to 5 minus 4x plus 9. Now if I want to write it in standard form, see standard form and index form is one and the same. The only difference is standard form we don't expect you to write the 0 coefficient. In index form it is compulsory that you write 0 coefficient. So how to write it in index form? See, starting with the highest order x raised to 5, then it is 4x. Few terms are missing. Which terms? X raised to 4, x raised to 3, x raised to 2. All this you have to write on your own with 0 coefficient. Then minus 4x as it is and plus 9. This form is nothing but index form. A very important note is written here also. Let us understand that. Degree of the polynomial is nothing but number of terms in the index form of the polynomial minus 1. Okay. So write this also as an important point to remember. Now with the help of this concept, let us try to solve few sums from the practice set, that is question number 7 now. Write the following polynomial in coefficient form. What should be the first step? To write the given polynomial in standard form or index form. x cube was there, few terms were missing, square and x, so that I have written with 0 coefficient, and the constant with the sign, that is -2. Okay, so how to write in coefficient form? For that what you will do, collect the numbers 1 0 0 -2. So this 1 0 0 -2, this is nothing but the coefficient form. I hope the concept is clear. Look at the next one, 5y. It is already to the last term. See, 5y, y means y raised to 1. After this what should be there? A number should be there, that is constant. It's not given, so you can write 5y plus 0. Now collect the coefficients 5 and 0. So the coefficient form will be as easy as 5 comma 0. I hope these concepts are clear. See, this was cube, so we took square, then x, and then the constant. It was already y raised to 1. We don't want anything less than that, so thus the constant is to be added, so we write it as 5y plus 0. Okay, so the coefficient form will be 5 comma 0, right? So write this fast. Let us see the next question. The next question is 2m raised to 4 minus 3m square plus 7. So standard form, after 4 3, then 2, then m, and then the constant. So whichever terms are missing, we will write it with 0 coefficient. So finally the answer will be 2 0 minus 3 0 and 7. Just the numbers. Yes, I hope it is clear. The last one now, fourth one. Only a number is given, variable is not given at all. So this itself is its answer. Don't try to insert any variable in that. This is a last term, this term. Okay, so for this the coefficient form will be the number itself, that is -2 upon 3. I hope all these sums and this concept is clear to you, right? Okay, let us move to the next question. Write the appropriate polynomials in the boxes. This is question number 9. This is actually an activity question. I am not solving it. I would like you to do it. I'll just revise it quickly. I'll discuss it with you. We know what is quadratic polynomial, cubic and linear. Quadratic means degree 2. So out of this, for quadratic polynomial, which are the ones which you will write? X square, see degree is 2. 2x square, do not consider the number of terms. We are only concerned about the degree now. Anything else? Yes, 3x square plus 5x. These three will be considered as quadratic polynomial. The next is what? Cubic polynomial. Degree should be 3. Don't count the number of terms. Only see the highest order of the variable. Correct? So this is cubic polynomial. Anything else? Yes, one more. X cube plus 9. So these two should be included in cubic polynomial. Linear means what? Degree should be 1. Can you see anything here? Yes, x plus 7. Anything else? No. So degree 1, so you have to write only one number, that is x plus 7 in linear polynomial. Binomial. Binomial means what? Now number of terms have to be considered. 2 terms. Correct? Same way here also 2 terms. So these two will be included in binomial. Correct? Then trinomial. Trinomial means 3 terms. So you have to consider only one. There are 3 terms in this. So this is to be written as trinomial. And the last one is linear. Linear means only one term. Don't see the degree. Term you see. Only one term. So there is only one thing, that is x square. So this will come in linear. I hope this tabular column, this activity is understood to you. So please complete it on your own. Okay. After this, I am just taking one small question from practice set 3.2. This is absolutely easy. So let us finish it off. There are 8 trees. Now what you have to do is use the given letters to write the answer. There are 8 trees in a village. If number of trees increases every year by b, then how many trees will be there after x years? Let us understand this with the help of an example first. Suppose there are total 7 trees in a village, say. Okay, every year number of trees increases by 3. So first year number of tree increases by 3. Second year number of trees increases by 3. Third year number of trees increases by 3. Yes, we need to keep on adding like this, right? So how we'll get the total number of trees? 7 plus 3 plus 3. 7 plus 3, 10. 10 plus 3, 13. 13 plus 3, 16. So total number of trees is nothing but 16. If number of years were less, we would add like this. Suppose there are more number of years, then what is to be done? How to get a relation? How we got number of trees was 7. To that, what I have added, see this, number of years is 3 and every year it is increasing by 3. So it means I have added 3 into 3 here. Yes, so what do I get? 7 plus 9. 7 plus 9 is nothing but 16. I hope you are understanding this concept. Yes, now let us relate it with our given sum. Okay, now see here, A was the number of trees in that village. So A. If the number of trees increases every year by B, every year it is increasing by B. So the first year it will be B. Second year it will be B again. Same way till how many years? How many trees will be there after X years? So I need after X years how many trees will be there. Okay. So what is to be done? As I have done explained you just now with an example. A is the number of trees that will be there. In order to get number of trees in X years, what I have to do? X into B or B into X. This will be number of trees after X years. Correct? Now how to write it? See this. Number of trees in a village is A. Number of trees increasing every year is B. This is what I have explained just now. So number of trees after X years is nothing but A was already there. B, every year it increases by B and number of years is X. So it is nothing but A plus Bx. Okay. So that will be the final answer. There will be A plus Bx trees in the village. I hope this is clear to you. You just have to frame, nothing to solve. This is hardly one mark question. Okay. See the next one. For the parade, there are Y students in each row and X such rows are formed. Then how many students are there in all in the parade? Now let us try to understand this. Suppose in the assembly you are standing like this, okay, in a line. 1, 2, 3, 4 students in each row. Yes, like this, Y students are standing in each row. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now see this. For a parade, there are Y students in each row. How many students in each row? Can you tell me? 4. And X such rows. How many rows I have made here? 1. Yes. How many rows I have made here? I have made 1, 2, 3, 4. 4 such rows. Right? So total number of students in this will be what? Am I going to add like this 4 plus 4 8 plus 4 12 plus 4 16, or I will simply do 4 into 4, 4 like this and 4 like this. 4 into 4 will be how much? 16. This is a concept to be understood in this sum. Let's see. Total number of rows is X. Number of students in each row is Y. So total number is nothing but total number of rows into number of students, that is X into Y, XY. I have explained you with the help of an example just now. Is it clear? So write these steps. Final answer. There are in all XY students for the parade. Okay. So write it quickly and move to the next question. The next question is this. The tens and the units place of a 2-digit number is M and N respectively. Write the polynomial which represents a 2-digit number. Now this I can explain you with the help of an example. Suppose I have the number 72. The digit at the units place is 2. Correct? So this is to be multiplied by 1. The digit at the tens place is 7. So this is multiplied by 10. Place value. This is the expanded form. I hope you know this. This you have already learned in lower standards. So 72 can be expanded as 70 plus 2. Why like this only? Because 7 is in tens place, so we are multiplying by 10. 2 is in units place, so we are multiplying by 1. See, 70 plus 2, we get it as 72. Now what they are telling, in the units place and tens place, what we have in this case, a 2-digit number is found. We will write it again. See, in the units place and tens place, 2-digit number is found. The tens and the units place have M, tens place is M and units place is N. How will I find the 2-digit number? Just now I have explained, since it is tens place, this will be multiplied by 10. 10 into m plus, this is in units place, so this will be multiplied by 1. So what is the number that is formed? 10m plus n. I hope it is clear. Very easy. Yes, very important. Now how to write it? Digit in the units place is n, digit in the tens place is m. So the 2-digit number will be 10 into digit in the tens place plus digit in the units place. So as easy as 10m plus n. Write the final answer. The polynomial representing the 2-digit number is 10m plus n. Yes, very important. I hope you have understood this concept. Yes, and whatever we have learned today you have understood. With this, I come to the end of this session. Please write all these sums so that it becomes more clear. Remaining will continue in the next session. Till then, goodbye.